send it to you, yeah?
As we learned, he's now becoming an NFL tight end. So
True.
Nice. Okay, guys. So welcome back to Bricks, Bucks, and Bytes. We have an interesting episode today because we have two call-ins, both from founders and technical people within the robotics space. So we're going to dive into a little bit about robotics and dialing in a bit later. We'll have Tessa from Dusty Robotics, and I think everyone who listens to this probably has heard of Dusty Robotics. Um, I think I can easily say that they're one of the most reputable companies within the construction tech scene. Have built a fantastic business. So we're excited to talk to her. And then we will have a relatively new kid on the block, which was Bedrock Robotics. So Kevin Peterson, who's the Chief Technological Officer of Bedrock, will be joining us. And Bedrock, as you may or may not be aware, were founded by ex-Waymo engineers. And Mo, Mo, you must have been in a Waymo before, as you're based in that part of the world. Unluckily for us over here in Europe, we have not experienced autonomous taxis, or autonomous vehicles yet. Patrick, in Germany, does it exist?
I think we're still trying to figure out a few things before that with German bureaucracy. Yes.
Fair enough.
Yeah.
So,
Yes, I love Waymo. I think it's like the best way, to get from A to B.
very nice. Great that you don't have to talk to the taxi driver for the long journey.
It's also more safe. I feel safe.
Okay, good. More safe than a human driver?
Oh yeah, 100%.
I mean, have you driven with some of these human drivers, Owen?
I mean, when you go to southern parts of Europe, maybe it gets a little bit frightening. London, not too bad. Actually.
Or New York, or so.
Yeah, I mean, it's actually very novel for us, for us people having not experienced it before. So I think it would be a great experience. When we're over there, we'll test one out.
I recommend a trip to Dubai or Delhi.
I have been in a tuk-tuk in Sri Lanka. I think you're casting me back, and that was pretty. I don't want to say terrifying, but slightly uncomfortable.
I think you'll feel better in a Waymo.
Okay, cool. Yeah. I'm ready for it. Yeah, so Bedrock, they have come out of stealth maybe a month or so ago now with an $80 million round. And they're developing self-driving kits that can be retrofitted to large construction machinery. So we'll find out a little bit more about that. And what's even more exciting is last week, maybe the week before, Field AI announced another funding round, which brings their total funding to $405 million, and a company that's now valued at over $2 billion. So there's lots of money going into this space, and lots of people coming from other, say, bigger tech companies as well. I think the Field AI team, a lot of them from Boston Dynamics, and even NASA.
Yeah, mostly research centers. NASA, JPL, DARPA. Yes. So they won the DARPA challenges. I think they have like one of the smartest or the smartest teams I know. So I think the team is incredibly good. So that's like extraordinary. So I've never seen a startup team that's that good as founding team. Yeah.
Nice. Okay, so all right, let's just open a very open question then on this. Patrick, as someone, and we know you are a fan of robotics within the industry, what is your current sentiment towards robotics? How do you feel?
Yeah, extremely bullish, but we have barriers to adoption still. And so let's maybe dive in. So I'm looking at robotics within the project economy, construction being a big part of that, infrastructure, renovation, but also lot size one manufacturing in general, as long as it's industrial enough. I'm not really looking into retail type robotics. So for example, restaurants, etc. If you look into even that, right? Even that is being developed, exactly. But let's say collecting plates and bringing them into the kitchen. Like that's fairly roboticized. If you ever fly to East Asia, actually, it gives you a very good window into the future of how robotics is already transforming the pink collar industry. So I'm looking more into project economy. As you guys know, big fan of that. 25 to 40% of the world GDP is actually developed in projects, and robotics will transform it a lot. We're spending a lot of time in China currently, actually. So we have backgrounds, we have connections, blah, blah, but we're also dedicating time to that because that gives you a massive window into what's truly happening. Now, there's actually a financing gap, believe it or not. So that sounds very counterintuitive to what you guys are saying, right? Oh my God, here's 300 million for field AI, and here's Bedrock with 80, and this and that. Equity is there, but there's still a financing gap as you grow these kinds of robotics companies. So that's one. Two, there are certain subcategories of robotics which are actually really poised for breakouts. So cobots is one subsegment where you will see breakouts. Welding robots is another one, which is oftentimes using cobots. Cleaning of bathrooms in commercial buildings is another one that is absolutely poised to break out. So we are going to see adoption, but it will be subsegment by subsegment. And so construction right now, there's not that many that I would say are just yet ready for adoption. I would say the first one is probably going to be transportation of material on construction sites. So that's sort of in a very rough, broad strokes kind of a way, a lay of the land here.
Mo, do you have a follow-up, or do you, how are you feeling?
Just going to what Patrick said, I think transportation of material is like pretty big in Japan. I think they were already doing that or started building robots for moving material 6, 7, 8 years ago. Yeah, so they were very much looking for, because now they have, I think, the largest labor shortage coming up in construction in Japan. So they're spending already, 10, 15 years heavily to see, okay, how robotics can change the game for them. So this is like a very big push, and it's a totally different attitude towards robots, maybe also culturally, and the big need in Japan. So if you go there, that's like, say, oh, this robot exists. Oh, this already moves. Oh, they're using this already, transporting material. And I think, like for FIDA, if you're successful in construction, you can do everything else. So I think the hardest problem is construction. And there's like all these barriers, and it's a hard place for a robot to move. It's always changing. You cannot pre-plan everything. So you have to have like a very high degree of autonomy to move around construction. And that's like what Field AI is building. So that makes it really, if that works, then the execution robots, because they're more a software company than just a robotics company, so built on top of other robots, that will support many other robots to do their job.
Mo, do you know if Field AI's mission is to or their plan is for fully autonomous robotics, or is it to also include, and the technology they're developing will also include an element of human and robot collaboration?
I mean, the collaboration would be on site if he hands you the material over, but the robot itself is fully autonomy. Should be.
And the reason I ask is,
my understanding,
Yeah, the reason I ask this is because we had an interesting conversation with someone who's researching this for a large AEC company, and their research and what they're currently looking at is really this whole concept of the human-robot collaboration, and about how machines would be adopting humans as opposed to humans adopting machines, if that makes any sense. So how the two can work in tandem as opposed to full autonomy, which I think is quite interesting, because I think it's an important point to note, because when you talk about robotics, people probably assume full autonomy to start, which within construction we know is extremely difficult and is probably a way off the horizon yet. What do you guys think?
I think there are two different things on autonomy. I mean, one is to get from A to B and having not a human remote control you, or somebody uploading a model, then you have to navigate it and plan your mission. So if you build a robot which understands a goal, has a mission, that's autonomy. But then the robot can work with a human on its goal. Yeah, so they can, the robot maybe hands you over the tool, or does some part of the welding. Somebody comes, does some part of that work together. So I think you can collaborate, but the robot doesn't need all the time the input of the human. So it's less remote control. So it understands the task and does it. So it's like ChatGPT. You give it a task, a research task, and does the research and comes back for it for you. Yeah, so it's less Googling.
Yes, Patrick, what do you
Owen, did that person actually give a definition of collaboration in that context?
think? I can't remember exactly. I probably didn't dig as deep as such a question because I'm not an expert on the subject. But yeah, it's a good point.
So, because my answer would actually depend a little bit on that definition. But if the collaboration is defined a little bit loosely, as in, okay, any kind of handover between a robot within a larger workflow, robot completed a task and the human continues the workflow from there with the next task, if we define that as collaboration, absolutely going to happen, 100%. We see that in factories, we see that in, I always call it the window into the future. By that, I mean East Asia, Japan included, Korea included, China included, even Singapore to a degree. We see it. It's exactly what's happening. And so on construction sites, my personal expectation is that besides the hyper-verticalized, hyper-specialist robots that are actually gaining traction and adoption, take painting robots being one of the earlier categories, Mo, that we have seen, right? So besides that, I think material movement is actually going to be the one that is truly going to be scaled up first. And so that's the classic example of this kind of definition of collaboration, right? Because here you have some autonomous or semi-autonomous platform that actually serves the movement of material from mostly on a large construction site and mostly on one floor or ground level from A to B, and then a human will pick it up from there and actually continue the workflow. So in that definition of collaboration, I would say it's absolutely the norm and what will happen. If it's more like, I'm saying it cheekily, if it's more like hand-holding and working super intertwined, I would be quite skeptical. If it's remote control or gamepad control, that is another way how collaboration actually is going to happen. We're already seeing that in, for example, PV products and certain robotics that we looked at there, where it's actually quite good. Because there the problem that you can solve is not necessarily that you eliminate the labor. It could be that you actually eliminate the strain on the labor. So for example, back aching tasks, etc. And so they are gamepad type collaboration. But with, let's say, semi-autonomous features where you, for example, make sure that it doesn't fall down a ledge if, through the sensors you're noticing certain security risks or safety risks, etc. I think that's also, already happening and quite likely. But I wanted to say, Mo, what you said earlier, right? So if you can make it here, you can make it anywhere, the New York logic of robotics. I struggle with that, man. I struggle with that because if you have that kind of a logic, you can kind of always say, oh, let me become even more complex. And in the end, it's enticing to build a fucking Ferrari and burn through a lot of money without actually have it delivered anything. But then you say, hey, but I've perfected it so much for this that I can abstract it away. I struggle with that logic, I have to say. What about you?
No, because I think, construction has a lot of obstacles which you would meet also somewhere else. Yeah, on a plain street. Let's say there was, back then, we brought the first Boston Dynamics robot to the construction site
I
with
remember.
Hansa Fabs, and I don't know, it was like 2016, 17. And we did like the first experiments.
That was HoloBuilder, yeah?
Yes. So we had a big collaboration with them. And then was like one day the robot would just stop. We didn't know why it's not moving forward. There was just a sheet of plastic in front of it. Yeah. Nothing exposed, so it could walk over it. Yeah. but it was a little bit windy, and I was like moving a little bit, and then the robot would think, "Oh, that's water."
Interesting.
Yeah. So that knowledge now, if you take it away, it's the same like on a street. Yeah. So if you can see, no, but you have 1,000 things which you have also somewhere else happening on a construction site, but in a much more dense environment. So it's not that the problems are more complex or harder, but you have them all on the same time.
Yeah.
So if you
Uh-huh.
are on a street, it would take you maybe, no, I don't know, 1,000 miles walking to find that plastic sheet moving and learning. On a construction site, you learn it directly. Yeah.
Mm.
So you learn everything which you need also outside of construction. It's like not self-driving cars have to drive so many miles outside because now they see then everything which is happening and so on. But if you do a robot in a construction site, it sees so many different things, which are also real world scenarios for everywhere else, which can happen. I know a water bottle. So there's like 1,000,000 water bottles on a job site. Yeah. So if you go to a construction site, there's a lot of plastic water bottles lying around. And you have to understand what is it? Is it standing, falling, especially on the early days? Yeah. Can I step on it? Do I need to move around it? What is the structure? And that's something which is a real world problem if you walk in, let's say, in a larger city around with your robot too. Or if you do put the robot into a stadium for, I don't know, night routines, watching. So that helps really. So it's not about the complexity as we think, but it's like the use cases are just real
Yeah, more broad. You
examples.
get more bang for your buck in a construction environment. Just before Tessa is in the lobby, she's about to join. So just before, I don't know, maybe I'll leave this with you to Google yourself after. But there was a project recently in China, and this is the description on the headline where China just resurfaced 158 kilometers of highway using only robots and drones. So take a read of that if you get a chance. Good. Hey, Tessa.
Hey,
Tessa.
guys.
Hey, how's it going?
Tessa?
We have two. So
It's going
we have.
good. Hey, Patrick, Owen, Mo.
You say like you know him already. Do you know this guy? He just joined us for this
I
conversation.
do.
Okay.
I do know this guy. What are you doing here?
Co-host
He's our
the,
Dustin.
Robots podcast. Yeah.
Awesome.
Hey, Tessa. We were just talking about what's your views on autonomous robotics within the construction industry?
Wow, right in.
Well, that's like a big question.
Yeah,
Obviously, everything's going to be built by robots in the future.
Okay, cool. All right, thank you. See you.
No, let's start like this. On Tessa, remind
Go
us,
for it.
what is Dusty doing? I think there shouldn't be any soul that is listening to this that actually doesn't know what Dusty is doing, but let's make sure.
Well, I'm going to frame it slightly differently for you guys. And I'm going to give you the bigger picture view because I love this podcast and I want to treat your guests to something different. Can you guys hear me okay?
Yeah.
Of course, yeah.
All right. Awesome. So Dusty is intelligent orchestration for the connected job site. If you think about it, one of the first job sites I set foot on, it was a Stanford campus building. And there were, I was talking to the project exec. He had 1,000 people on site that day. And he said his job was like being a kindergarten principal. He had to make sure everyone showed up for work, that they were sober, that they went to the right place and did the right thing. And that was a monumental task, right? That's why he got paid the big bucks. And so I realized that construction is really about orchestrating the flow of people, materials, and robots onto job sites. And so what Dusty does is it lays the foundation for what we're calling field intelligence. And it starts by automating layout. You don't think about it, but layout is kind of the fundamental thing that directs people to build the right thing in the right place. Without layout, you wouldn't know any of that information. And so we have robots that print full-size building blueprints on the ground. which is the first step towards orchestrating all the work that's happening on that site.
Very nice. So you're back to day one of your first day on the job site. It's funny how you spend all the time building, and you always go back to your roots eventually.
Well, that's how it starts, right? That's where you learn about the problems, and we're really motivated to solve those problems.
Okay. Does anyone want to follow up on this specific question, or if not, I do have something.
I have more broad questions, but let's first zone in perhaps on Dusty, because I think it's a fascinating business that you're building, Tessa. So Owen, let's maybe stay there if you like.
Go for it. Yeah. Okay, Tessa, maybe this is a really stupid question, but I have to ask it. You mentioned that like printing blueprints was the place to start. What comes after blueprints?
11% of the people in the field always have the information they need to build. That's a staggering statistic. That means that almost 90% of the people who are out there trying to do their work, they want to do their best work. They take pride in their craft, and they don't know what to do. So obviously getting layout out there is going to help them, because it's going to bring a lot more of that information under their boots so that they can see it. What we're building next, I can tease a little bit, is leveraging AI to bring even more of the information that's normally stored in the cloud developed in VDC, and bringing that to the hands and eyes of the people who are out there in the field.
Okay, makes sense.
Oh, one.
Go for it, Mo. Go for it.
Maybe because everybody doesn't know what means printing on a job site with a robot. You want to maybe visually explain how a Dusty robot looks like today, so people don't think there's a printer going around and doing it, but how it looks like, and get a feel how it works, because I think that's like the very interesting part if you have not seen it.
So the way layout gets done today is typically people on their hands and knees using measuring tape and snapping chalk lines to put marks on the ground. It was invented by the early Egyptians and hasn't really changed much in 5,000 years. Wow. And so what Dusty's field printer looks like, you can picture a vacuum cleaning robot with a printer strapped to it. It's a little 3-wheeled robot that navigates the job site on its own. It ingests your BIM model or your AutoCAD file, and it prints that with a 1/16 of an inch or a millimeter accuracy on the slab. And so as it's going around, it's spraying ink on the floor, and that ink traces out the patterns in your blueprints.
It's such a sweet solution. I mean, it's Tessa, I saw a presentation that you gave maybe 2 months ago, 3 months ago. It was definitely this year, I think. And you showed you recounted the steps that it took you and all the exploration that it took you in order to land where you are. And like, if someone hasn't seen it, I can really recommend going back to that link and watching you. It's like 45 minutes video, I believe, but I thought it was very informative. I love these, I don't want to say origin stories or genesis stories. I do love them too, but I think in this specific case, it's worth watching for a different reason, because you literally recounted the steps through the forest that brought you here. And so what I realized is just how obvious but non-obvious this was. It was when you presented it to the customers, they were like, yeah, of course this would make sense. But if you're a generalist person from any kind of trade and you're thinking about robotics, so what do I apply? You would never come to printing the BIM file onto the floor. So talk to us about that whole experience of this obvious versus non-obvious.
It was definitely not obvious from the beginning. When we first founded Dusty, Phil and I started exploring different ideas. Like, neither of us had ever done construction before, so we didn't know what happens on a typical job site, and it was all this big mystery. And so as we were exploring the site, we would make hypotheses. We're scientists, and so we would develop hypotheses about what robots could actually build successful businesses around. And we had ideas. We thought about roofing for a while. That was one of our earliest ideas. Now there are a couple companies in that space, which is awesome. We thought about materials handling. We thought about crawl space inspection. We thought about cleanup. Actually, cleanup was one of our more, we thought that was going to be like a more successful idea because it happens on every single job. It's not too hard of a technical problem. Like, we've got Roombas in homes. And so, an industrialized Roomba for construction, that's not a leap, right? But we didn't like it because it wasn't a high value task. And so we kept looking. And it wasn't until we were actually doing cleanup ourselves to learn about that problem and spec out a solution that we actually discovered layout. And once we discovered layout, we quickly realized that there was so much value to doing layout well, that was kind of the tipping point that made us realize that this was something we wanted to commit the next 10 years of our life to.
How long was that process from you thinking about the first thesis and then actually settling on the printing?
It was about 6 months.
Okay.
So 5 to 6 months. So we started the company in April and started talking to our first construction people that month. And I remember there was a Robo Business conference in October of that year, and that was where we bought our first hardware.
Sweet. I mean, 6 months, you definitely saw a lot in that time frame. And then how did you know this was going to be it? Like, how did you decide, okay, we're not going to test anything further?
Because we had come up with so many ideas, it took us a little while to gain conviction in this idea of automated layout. And I remember a couple of things that helped us build that confidence. One was discovering that so many people have tried to build automated layout robots. DPR is the obvious one. They had a project called Project Lion, where they actually hired a robotics company to build them a couple different layout robots. It wasn't successful. They never actually got something that could act with enough accuracy and speed to make it viable. But they invested several $1 million in it over the course of several years. And so anyone who puts their own money into solving this problem means that it's a real problem, right? But that plus, it felt like almost every other person I talked to showed me a picture on their cell phone of their own automated layout robot. They like took a Roomba and they strapped a pen to it and they tried to program it to like draw lines on the floor. Everyone's got their own story. Like every little, construction geek has tried to tinker and build that. And so all of those details and those anecdotes made us realize, hey, people actually want this thing. And so if we could build it, there's a market for it.
What a great indicator.
Maybe a funny story to a pen on a Roomba a robot. I remember we were speaking to one of your team, Tessa, and they were on site at the time, and it was raining. And do you call it ink that gets printed onto the slab was not impacted by the rain at all. And in our heads we was thinking, oh, okay, maybe it'll smudge or whatever. But if you use a pen on a Roomba, I'm sure the rain would have just completely washed it away, and that would have kind of
that's amazing.
Nullified the value of what you do. But other question maybe is how did you quantify the value of this layout issue, and how did you know it was something worth pursuing? And the reason I ask this is because typically in construction it's not something that is like a line item within like the works list or whatever. So it's like a hidden, maybe to Patrick's point earlier, which is not obvious at first. So how did you get to that?
Yeah, that's funny because all the people that we were talking to, like, VCs and advisors to the construction tech industry, were telling us you got to find a problem that has a line item, right? Because if there's no line item, there's no budget for it. And so that was one of our bigger concerns at the beginning of Dusty, because there is no line item for layout, right? It doesn't show up on its own in the budget. And that is one of the challenges that we've had to overcome to get automated layout as widely deployed as we have. And so our philosophy around what kind of tech do we bring to, what kind of innovation do we bring to construction has always been, we are aiming for a 10x better solution. And the way we thought about that with layout is like, if you think about how layout gets done today with guys on their hands and knees using chalk lines and measuring tape, using a robot to do it is 10x better. It's 10x better in speed, 10x better in accuracy, 10x better in the amount of information you can get on the slab, right? And because of that massive improvement, our customers, they don't want to go back to how it was done before. And so that is overcoming the challenge of there is no budget, line item in the budget for layout. People are making room in their budget for this.
Very good. Mo, do you
Tessa.
have something?
Tessa, if you want to talk more about Dusty, we absolutely can, but I'm dying to talk robotics learnings with you and robotics philosophy, because you obviously, you went through so much experience here that I think you're preparing a whole new generation of robotics founders that enter construction that can, stand on your shoulders and build here. So I want to tap into that, but if you prefer, we can also stay on Dusty a little bit longer. You tell me.
That's okay. Let's talk robots.
Yeah, wait,
right.
one thing before we go there. Mo, do you have anything more on Dusty? And Patrick, my guess is that you're alluding to this 99
I can do the segue
learnings.
question between both.
Okay, go for it. Brilliant. Do it.
I think one important thing is you made it also very simple to use over time, and also to use, not needing so much extra hardware, for navigation and positioning, and how you get the model onto the robot that it knows what it does. I think that interface also got simplified, that everybody can use it more or less. How was that process, and how important was the simplification of your UX for the robot?
So this is my second robotics company. My first robotics company, Savvy Oak, was building robots for the hospitality industry. And our user back then was the front desk clerk at a hotel. You can imagine they're minimum wage people. They're not college educated necessarily. They're, they care much about service and they want to deliver the best experience for their guests, but they're not technical. They're not highly trained. And so that was our first learning. One of the things we discovered at Savvy Oak was that the common wisdom in robotics at the time when we were building Savvy Oak was that it's robots are not fully developed. They still need human oversight. And it's sort of having like the driver behind the wheel in the driverless cars, like the safety driver. And so pretty much almost every other robotics company has like this team of teleop workers, maybe in a different country, that if the robot gets stuck, they can drive it out of its dead end and get it going again. And I realized through that experience that is not a scalable business model. We cannot bring a technology to market that requires experts to help it go.
You should tell that to the Tesla self-driving team.
Tesla self-driving drove me to work today, so I have no problems with Tesla. I love it, actually. So when I got to Dusty, right, I knew that in order to make this a scalable, sustainable business, it could not require any PhD level roboticist to operate. We had to be creating a power tool, because that's what our customers use on a day-to-day basis. And I'm really inspired by Steve Jobs and what he's done with the iPhone and the whole Apple ecosystem. Like, you don't need to go to a class to learn how to use your iPhone. You unbox it, you poke at it, you figure it out. And so that's my inspiration for Dusty. Is I've always wanted it to be as easy to use as an iPhone. We have to democratize construction tech. That's the only way to solve the skilled labor shortages that we have.
Beautiful. Love that. Okay, shall we go to so Patrick, you want to go to the 99 problems?
Yeah, we're now going reading 99 learnings and getting your commentary. No,
quick question: why did you not get to 100?
We needed to limit the quality, obviously. So 100 would have been the 100th one would have been a dumb one. No, but okay. Tessa and I, Tessa, you and I, we've been debating a little bit over this. I've been dying to have also the chance perhaps to just pick a few. And so we're not gonna, I'm not gonna do this to you guys. So I'm not gonna read anything of it, whatever, look it up. Tessa and I, we've been talking about this also online, etc. But there are 2 or 3, let's say, general philosophies overarching some of these 99 that we've written about that I wanted to throw at you. And the first one is one of the core learnings that we here at Fundamental had is just the dominance of accuracy. Sorry, by accuracy here, I speak about the sensors. Talk to us about that. Why do you, let's say, what does it make with you if I tell you, hey, accuracy is actually a moat in itself, and nailing accuracy unlocks so many other things in robotics, especially in construction?
Especially in construction. One of the first things I learned about in construction was everything has to fit. And the way construction's moving is towards more prefab, more offsite construction. And the more things move in that direction, the more accuracy matters. One of the enablers for the advances in construction, particularly offsite robotic construction, is that accuracy. And you can't get it without Dusty. And so we're becoming integral to the workflow of all of these people who are assembling things offsite, bringing it onto site, and trying to fit these pieces of a puzzle together in a limited amount of space. And so accuracy is, I think, is becoming table stakes for automated construction, and particularly robotic construction.
So how do you fix that as a robotics? I mean, as a robotics founder. So one of the things that I actually am enamored with is when you overinvest in sensors, and you almost pay too much, and you pay, let's say you design a platform where the sensors are over-spec'd for what you're doing now, but it allows you to perhaps then load other tasks later, sort of the SLAM discussion in self-driving cars.
Yeah, exactly. So one of the brilliant choices that my co-founder Phil made early on in Dusty's history was to use a laser tracker for positioning. A laser tracker is immense overkill for our needs, but if you think about it, the specs of a laser tracker, it's accurate to within 15 microns. No one in construction even knows what a micron is, but it's tiny. And so that choice has enabled us to bring a product to market that is much more accurate than anything else anyone has seen. And that is our differentiator and our moat. And that is part of that 10x improvement that I was talking about before. You, by building something that is so much visually better than anything that anyone has ever seen before, that is the only way we overcome the inertia in the industry and actually get this deployed at venture scale.
Love it. And one of the other things, and Mo, you have built hardware companies, so I'm really here I'm an informed observer, so feel free to jump in. But one of the things that I have learned from founders like you guys is when you actually overspec in the early days, and yes, you pay a little bit more, but etc. It's obvious when you hear me say this, but it takes a little bit of early realization. You can load new applications on an installed base, recalling an installed base and then speccing them up again with hardware. Like nobody does that. Like who does it, right? So overspeccing allows you to do new applications later.
Totally. In our second generation field printer, we actually have some sensors in there that we're not even using yet. They're part of the hardware base. And as we develop more software, we can actually turn on new applications that don't require switching out that hardware base.
Load the board. Load the board.
That's cool. I never knew stuff like that. Wow.
I guess you need a roadmap, no? So you should not have like too much in it. So there's like a roadmap cost curve somewhere, which makes sense to have it, yeah. But also not cost of engineering. There's so much things which goes in it, yeah.
So then I want to talk to you guys, and I know both of you have experience here. So another I think overarching theme of the 99 learnings, Tessa, is the choice between extremely proprietary hardware versus I go super dumb off the shelf. And I'll give you an example before I let you go. Super dumb off the shelf stuff and sort of repackaging, reassembling it. And then of course there's going to be software uplift. And so one of the most interesting robotics companies this year, to me, most interesting robotics companies this year was a founder, terrific founder in my opinion, that was literally taking a completely assembled product because it was ready, cost him 20,000. The components would have cost him also 20,000, and he literally bought the fully ready product, which was intended for a completely different industry. He bought the whole thing, and he then disassembled it on the shell, on the top hat, and he kept the whole drivetrain, he kept the chassis, and then reassembled new stuff onto it. And I was like, what a brilliant move. So talk to both of you, talk to us about that kind of philosophy.
That's something you can't do in software, right?
You
Well,
can lots of.
the equivalent for
can.
software is libraries, right? And components.
Yeah.
You know, it's all about reuse. Right? You know, do you build, do you buy? And so, like the first prototype we built at Dusty was actually based off an off-the-shelf hardware platform. We purchased the, oh gosh, what was the name of it? They're sitting in our museum right now. We have two of them. This is the chassis that I bought at Ubiquity Robotics, right? So they had this off-the-shelf chassis. It was basically like like a Roomba-sized thing, a little bit bigger, a little bit more heavy and industrialized, with two drive wheels and like the electronics to make them go. And that was about it. And a big, like, you know, cavity that you can put stuff into. And we built our first robots using that off-the-shelf base. We did that because it was quicker to get something to market, right? We actually earned our first revenue using the robots that we built off of that off-the-shelf chassis. And so anything that helps you accelerate your time to market, because in startups, especially in robotic startups, time is the one resource you can't get more of. And so time matters a lot. You have to figure out, how do you get the biggest, learn the most in the shortest amount of time.
Very smart. Any more on
It's
this?
like prototyping. You can see, you know, on the shelf, it's like a prototype. You can prototype with it and see how far you can go with it, and then again assemble something on top or build your own after you learned enough. I think that's like the biggest
I'm gonna
thing.
blow.
Right.
I'm gonna blow you guys' mind. So this specific founder and this specific company actually uses that for the mass manufacturing now. So they went to the OEM of the original, you know, equipment and said, hey, you know what, just leave the top hat, just sell me the chassis and the drivetrain, etc. And he's now become actually the biggest customer in the US for that specific OEM. It's also an interesting manufacturing and supply chain logic, actually, one that I hadn't seen executed by a robotics company so far.
Yeah.
It's all about time to market. How do you build as fast as you can? And if you can leverage existing stuff to do that, absolutely do that. But the thinking that we have here is that those prototypes that we built with off the shelf were just to help us learn what we needed to build for our final product.
Right.
And then once we knew that, we could make it smaller, we could make it lighter, we could add more sensors, right? And in order to get to that point, we had to go through that learning phase, because the reality is, like, you can't design it in the lab. You won't know until you bring it out onto a construction site what it actually needs to do. And you have to get that learning as fast as possible.
That's a perfect segue, Tessa, because one of the things that we've been learning ourselves as we work with robotics founders and observe successful ones, manufacturing tends to be not anticipated by a lot of robotics founders that are on their first ride, because it's complex in itself, right? I mean, building a company and then building robotics and hiring, like, you guys know how complex that is. And so then here's this additional. So at some point, you actually need to anticipate manufacturing, be it DFMA, be it supply chain organization, etc. Tessa, what is your advice for founders to anticipate the whole manufacturing scale up in the robotics company journey?
That's a hard one, because I don't think there's any one size fits all advice, right? It depends on the product you're building and its complexity and how many of them you need. I can tell you that we switched to a contract manufacturer after we'd built about 60 of our production units in-house. We didn't start from zero, and we also didn't wait until we had hundreds. And so building 60 in-house gave us the knowledge that we needed to teach that contract manufacturer how to do it.
Okay.
Because otherwise, they'd be shooting in the dark, just like us. And so getting that learning in-house was really, really valuable, so that we knew when we transitioned over what they needed to know in order to do it well. Because your contract manufacturer is never going to be as embedded in the product as you are. They're never going to have as tight access to your engineering team. They don't really know why you built it the way you did. And so you need to work out those kinks first on your own, I think, before you try to hand it off to someone else.
Very good. Tessa, maybe a last one or so would be about increasing the adoption of robotics. I think Built Worlds, I saw when I was researching for this episode, they released a report earlier this month, and between 2025 and 2024, the actual implementation and adoption of robotics dropped. So, do you have any thoughts about like what's difficult about getting these robots actually into construction, onto the sites, and people using them?
One of the sad trends that I see in robotics, and that includes construction robotics, is that a lot of people get into it because they want to build something cool. They're not in it because they want to solve a real problem for someone. They're in it because they want to build a robot. And so what I see is a lot of robotic startups building something cool. And, anything cool is going to get you a pilot on some site, and someone will try it out. But if it doesn't solve a real problem, if it doesn't have that sticking power, then you're not going to get it into production. You're not going to scale it up. And so I suspect that because it's been so much easier to build robotics, thanks to all these advances in hardware and better software platforms, we've probably seen that Cambrian explosion of robotic startups. And, unfortunately, just like with construction tech, the industry gets burnt out a little bit on trying all these things that don't really add value.
Mm-hmm. Very smart. Cool. Maybe we can squeeze one more question, Patrick. I can see you thinking.
There's
Or
one
Mo,
more
if you
in the
want it.
99.
Go
I
for
mean,
it.
then we're getting very granular here. Let me. Okay, I got one, Tessa. So a founder that used to work for one of the large IoT unicorns, then for another hardware company, that founded his own hardware company. Mo, you like this too, and perhaps you guys have a similar or different experience. So he taught me one thing. He said, Patrick, my boss in this, so he used to work for Withings. Withings was like is a very successful, consumer IoT company. And so he said, my boss actually taught me this. When you design your hardware for a 4 times uplift, so basically you can sell it for 4 times, obviously you get a 75% gross margin. But he said, if you design it that way, you will always build a profitable business. So that was the logic that they taught him at Withings. And so he has then implemented it into his own hardware company, bootstrapped, about couple million of annualized revenue currently. Fascinated by the business, they do really well. But what about this rule of thumb? Is that a real thing? What do you guys think?
I mean, that is absolutely true. Like you have to make money off of your product. Otherwise, you don't have a business. You have a hobby.
But what
Another
about
question is,
specifically
if you have nowadays maybe a subscription with your robot, I think if it's just sell hardware, it's a different pricing model versus having a robot which has a subscription to it. So if we have a robot and there's software components and subscriptions, I think the margins on just the hardware change.
Yeah.
So I think that's like a big
Absolutely.
difference. I don't know the pricing of
Yep.
what you do, but probably most construction robots will have a subscription and not just fixate on the price of the hardware.
Yeah. And I know we're at time, but our thoughts on that has always been that the hardware is the moat to allow us to build a thriving SaaS business on top of it.
Great one to leave us with. Tessa, thank you so much for joining us. Really appreciate it. Best of luck with Dusty.
Thank you, guys. I had a lot of fun.
Soon.
Good seeing
Thank
you.
you.
Take
care.
Ciao.
Bye, guys.
Very cool. Guys, we will summarize. We'll summarize that at the end. Kevin is in the waiting room, so let's get Kevin in here.
But Mo, my question was, so maybe I didn't phrase it correctly, right? But so so what this founder was basically saying is, hey, you need to design your entire hardware in a way where you can always get a 4x uplift on it. And so it was not a gross margin argument, because that one is obvious.
Okay.
But he was saying if you constantly design it with a 4x in mind, you will always have a net profitable business. Like, is that a thumbnail rule, a rule of thumb that you would subscribe to?
I don't know enough about it. I know when I did once this tablet manufacturing, like when it was like an Android tablet and so on, the margins were not that great on those. So yeah, because it's like a consumer product and so on. So that's like a little bit different maybe than hardware for B2B industrial hardware. I think it's also much easier to sell because that's less competition, especially if you're a German manufacturer. Then you get different profits out of it.
Yes, very German. Cool. Let's let Kevin in. Yeah?
Let's go.
Good morning, Kevin. What's going on?
Hi, how are you guys doing?
Hey, Kevin.
Yeah,
Morning,
good.
Kevin.
You're in San Francisco too, right? Mo is also there.
Oh, I'm actually on the East Coast today, but normally, yes.
Oh, okay, fair enough.
How are you guys doing?
Funny. Yeah, we're good. For this episode, I don't know if I already said this, so people listening are going to be like, "Why is he saying it again?" But Mo was actually considering whether he should do the episode in a Waymo for the occasion, but
Of course.
before we'd save that part for you.
Have you guys tried a Waymo?
I mean,
Well,
me, yes. I mean, I use it all the time.
Oh, yeah.
But
Yeah. Sadly, Patrick based in Germany, I'm in London. We don't have that technology over here yet in Europe.
Not yet.
Yeah, so sadly not. We're blessed with human drivers, or blessed. I don't know if you want to say blessed, but maybe there's a different term. Cool. Kevin, so before you came, I kind of set the scene a little bit. So Bedrock Robotics just out stealth with $80 million round, and you're developing self-driving kits that can be retrofitted to large construction machinery. So yeah, why don't you just tell us a little bit about how this came about, and you've gone from taxis to construction, and like taxis, which everyone can see and impacts everyone's life. I mean, construction does, but construction is a little bit hidden, I guess, compared to what you were at previously.
Yeah, absolutely. So I've been working on some form of robotics and autonomy for maybe about 20 years. Worked on the first self-driving cars back at Carnegie Mellon, and one of the first places that we spun that technology out to was mine trucks, where there are hundreds of millions of miles of a self-driving already, and that people don't really know about that, but that was my first exposure to this kind of space. And then later sold the company to Caterpillar to look at autonomy, and so then went to Waymo, worked on the trucks, and we figured out how to do a lot of interesting things there, and now we want to bring that technology back. We think the timing's right to look at construction.
And it comes at a very interesting time also with another robotics company announcing a very huge round, which we discussed earlier, Field AI. When you were inside of Waymo, was this an idea you were having with your other founders at the time, and it felt like the natural next step, or what did this come kind of after your stint there?
Yeah, I mean, I think I've been thinking about it for a bit, and when I joined Waymo, we really wanted to focus and launch the trucks, get the cars on the freeway. We did that, and then we were looking around and we were looking at the technology. Waymo paused the trucking program, and we were on the leadership team there, so we were sort of asking, do we stay at Waymo and push that forward, or do something different? And where technology is today for imitation learning, for these big foundation models, language, things like that, those technologies are now sort of perfectly positioned to be able to bring this self-driving technology into the space. And it was not the case maybe 3-4 years ago that was true. So the timing is really, really good. I think we figured out how to do a lot of things at Waymo that, certainly in my career, we didn't know how to do until fairly recently. It's a huge and interesting and super impactful part of the economy. So we felt that it was a really good thing to do.
Okay, I have one more
question.
question. Then Mo, can I just ask this one before I open up? Sorry, I'm being very selfish, I know, but could you just tell us, Kevin, like briefly, what makes the product so unique and special to this industry? Like, why is it like, why does it exist? Yeah.
Yeah, I mean, if you look at construction, certainly in the U.S. and I think elsewhere in the world as well, the number of projects that we can do is limited by the number of people that are available to do that work, particularly for heavy machines. If you drive by almost any construction site, bigger ones at least, you'll see a bunch of machines idle. And the question is why? At the end of the day, a lot of these projects are their timelines are determined by the number of people that they can get on site at any given time. So if you can automate big parts of the work, then you can you can start doing those projects faster. And I think we'll see an acceleration of the work that we do, building, data centers, buildings, housing, all the power plants we need to do. All of those are affected by the availability of people to do the work. So we want to be able to augment that workforce and accelerate things.
Yeah, nice. All right, you go, Mo.
My question would be, what is the product? So, I mean, they said you can be, if you retrofit a machine or equipment. So the question is, do you just do the autonomy driving? Can you tell us more if it's like also operating? How does it look, so that for the people who are listening in, then they're not on a website, they don't know depths on it. Yeah, how is the product and what it's actually doing, or what is there today and where you want to go with it?
Yeah, absolutely. So what we're building is a driver for heavy machines, and we're starting with excavation. So excavator is a tool, and what we sell is a package that that we can bolt on to existing machines, as long as they've got a drive-by-wire implementation. So many of the machines out there do. We bolt our hardware onto those machines, and then we've got an ML and AI component that sits on top. Those components can drive the machines. They think about the tasks that you need to do. So in the case of excavators, think about trenching. We think about mass excavation, and the goal is for that machine to be a drop-in tool that you bring to the site. You flip it on, it can do the work. So one of the key things that we think about a lot is how to make it really, really usable. Like, how do you describe the work that you need to do? Is that geometry? Is it somebody walking up to an operator today and saying, "Hey, I spray painted a line on the ground. You need to dig a trench that's 3 feet deep." We want to be able to do all of those tasks.
Awesome. I like really the idea that you say you're building the driver in it and not building the robot. So that's okay. I like the philosophy.
Kevin, what surprised you about construction so far?
What surprised us?
We only have 20 minutes.
Man, I mean, it's a super fun environment. Probably one of the most challenging things is how often things change, right? Like, if you look at self-driving, the description of the task is really straightforward. You're saying, I want to get picked up at point A, I want to drive to point B, and that's it. That's the whole description. The driving itself is very hard, and safety is very hard. But the task description is straightforward. Here, you can be on the simplest construction site on Earth, and every 2 days there's a change. And so being able to adapt to that change, I think, is like super, super important.
Patrick, do you have a follow-up?
So how do you deal with that I guess specific to Bedrock, but if you don't, I also understand there are certain things that maybe there's a time and place to reveal everything. I'll also take a more generic advice maybe to other founders, but curious then, like, what's the implication for you in the founding team role?
No, we there's a lot of implications. So first off, like, how you learn to build this product is a really integrated thing. You can just go drive a car. That's easy. And what Waymo has done is scale up hundreds of drivers that drive the cars around cities, and that's how they learn what driving is like. Here we actually have to, like, build a road, build a foundation for a data center, right? And in doing that work, you get to see what the challenges are. So one of the things that we're doing is integrating very closely with very select set of design partners who have invited us on site to be able to start doing the work. We do a bunch of data collection, we analyze what that work is, and then we build out the features to be able to both communicate with the machine and also do the work. That's the heavily machine learning thing. We train the system a lot like an LLM, so we look at lots and lots of data, and then we've got an imitation learning system that can learn to repeat the behaviors that we see on site.
I'm obviously, I was born and raised in Germany, so you probably hear it in my language color. So I'm not a native speaker. What I'm hearing you say is forward deployed engineering. Am I hearing you correctly?
I don't know exactly how you define that, but yes, yeah, we have a very our engineering team is looking at real construction sites every single day.
Okay.
Looking at issues on those sites. They tell our people and our machines, we got to go do something new. Today you're working over here, tomorrow you're working over there. There's a rock in the way, you need to deal with that. I'm going to sketch on a whiteboard what the plan is, and that needs to translate into a command for the machine. We're in the middle of it, and it's super fun. It's super fun.
Nice.
Mo, do you have one?
How does this virtual operator knows what to do? I mean, you said it now, okay, you sketch something, but how do humans collaborate with the machine? That was like a question we had very early on the podcast, is how is the collaboration between the people on site and then the equipment?
Yeah. So we're building this out in kind of real time right now, and we're still thinking through a lot of the elements of it. But the vision is that you have a bunch of different kinds of inputs to the machine. And so if you're building a road, you might have very detailed CAD. You really care that the ramp comes down at exactly this point. There's a slope that you have to build for safety, for sound. And those need to be in a very specific location. And so one of the inputs has to be CAD or surveys. Those already exist, but we need to translate those into what the machine thinks about. There are other sites that are much more dynamic. So we're working on a foundation for a factory right now, and there's bad foundation material. Dirt is like river silt, and we need to clean that up. It's not really clear on day one like how deep you need to dig. There's an idea. You need to dig a couple feet down, 2-3 feet down, but the machine really has to make that decision. So the way we train the system is by looking at what people would have done in those situations in before, and we tell it, roughly you're going to dig 2 or 3 feet down, but you're really just going to strip this whole surface. So you give it an area, and you say approximately 2-3 feet deep, and then it learns based on looking at many other projects and asking what would have been done in that situation before. So it's really conditioned on the scene, on the setup, and on the description of the task. And then you could also imagine maybe a couple more inputs. One of the fun ones, we haven't built this out yet, but we're excited about it, is the idea of actually having natural language as an input, right? So, LLMs and ChatGPT you can chat with. There's no reason that we can't build those same interfaces into these machines. So we saw one case where people were scooping up water from a puddle and moving it to another one with an excavator. And how do you even describe that task? That probably is natural language. So that's coming. And then there's kind of a fleet view too. Sorry.
No, that's smart. Yeah.
Yeah.
Let's go. Okay, cool. Kevin, I was going to ask, Mo and Patrick, maybe correct me if I've got the company confused here, but and what they were doing. But from what I remember in this space specifically, there was a company called Built Robotics who raised, I think, over 100 and definitely over 100 million, and looked like they were in a similar space to what you guys are doing, but have now pivoted to is it solar piling? So do you see any you've obviously come in after the pivot that they've done. Do you see any kind of advantage from being the second mover within the space, or did you look at them when you were thinking about the product and so on and so forth, and what does that look like?
Yeah, absolutely. I think actually Noah went through the same incubator as my last company, Noah Reddy Campbell, who's the CEO of Built. I've got a ton of respect for him and have talked to him a whole bunch of times in the past. Their initial vision was very similar to what we're looking at, but I think the timing really matters. So if you look 5-7 years ago, the way that we built these behaviors was by hand. You would have a bunch of engineers who sit down and write down, okay, I'm digging a trench, and so the attack angle of the bucket needs to be at this angle when it hits the ground. I'm digging a certain depth. That's a line of code. And what we saw in self-driving is we were doing that for a long time in self-driving as well. What we saw in self-driving was that leads to huge teams, a lot of complexity in the software, and you move very, very slowly. You need a ton of funding to go after it. The machine learning techniques that we have today, that sort of came about in the last maybe 2-3 years, unlock a lot of that. And certainly on the safety side, we really understand how to build machines that can be right next to a person, right next to a pickup truck, and do something safe. We didn't know how to do that before. So all of that's really transformed. Don't want to compare directly. I think they had their own journey, but I think we're in a much better position today as an industry than we were 5-10 years ago.
Cool. Patrick?
I'm actually curious, Kevin, before I let you go. So we discussed earlier over-speccing early. So basically loading your board with way too much sensors or etc. It sounds to me like you're still figuring a lot of the actual product design also out, but you've been there, you've done that. What do you think of over-speccing?
Over-speccing your hardware?
Yeah.
I think in a prototype you really do want to add more than you think you need. I've definitely done that in the last design in the last few designs. At Bedrock, I think we have a much better idea of what we want to build just because of the experience that we've had. I think overspec'd it still a little bit, but if you look at cars or vehicles that we built 10-15 years ago, you probably would have doubled the number of sensors, tripled the number of sensors, tried a bunch of sensors that have different characteristics, and put them all in the same vehicle, collect the data, and see what happens. Today, we know how to use computer vision. We know where a LiDAR is going to be super, super important. We know how to do pose estimation, things like that. And so we really have a concrete design that we could start from and get going immediately. So I'd say we're 10% over designed right now. Yeah.
You've been with Waymo, so you know that what cameras and SLAM cannot do. So,
yeah, absolutely. Absolutely. Yeah. And then also where the industry's going, right? Like even Waymo, when I started at Waymo, it was mostly focused on LiDAR. Now there's a lot of emphasis on camera. We built a lot of like long range camera detection systems for highways. And you see Tesla runs entirely off of camera. Very impressive.
That was the cheeky comment. Yeah.
Yeah. So, yeah. Still waiting to see them go driverless, but
you and me both.
It's a balance.
Hey Mo, do you have another?
No, I think
no.
With robots and job sites, what's always what do you use? Just a camera, or you put LiDARs or other systems? Yeah, so I think sensor fusion is the way to go.
Yes.
Explain that.
Yes.
What is that?
What is
sensor fusion?
Yeah.
I think Kevin can explain it better than me.
Sensor fusion.
Sensor fusion.
Yeah. So sensor fusion is the combination of the different sensors. You might have a radar, a LiDAR camera, all pointing in the same direction, or you might have multiple cameras, and there's different versions of sensor fusion. But you want to add all of those sensors together and give yourself the best answer. If you do it naively, those sensors fight, and they will cause performance issues. If you do it well, and balance all the sensors and use them for where they're strong, then you actually get a much better performance system, particularly when you're looking at safety. And so sensor fusion is a huge part of what we think about. Yeah, absolutely. And by the way, we think multiple sensors together is better than just one.
Interesting. I've got a question that I've been dying to find the answer to for a few years now. So let me preface this a little bit. And the person that I need to go back to on this question is actually my dad. So my dad owns a groundworks company over here in the UK, small business like in the UK, but does a lot of like earthwork moving, excavation, pouring concrete, so on and so forth. And I'm regularly on his case, like, are you looking at the future? Are you looking at like autonomous vehicles, so on and so forth? And him being a 60-ish-year-old business owner, he's kind of like, if it ain't broke,
Sure.
don't fix it. It's not my thing. Oh, and by the way, how do they deal with cables and obstructions under the ground? Because we all know that surveys of cables and what are quite inaccurate. Certainly over here in the UK, in my experience within the industry, we pay for underground surveys of cables, and yeah, is it worth the paper it's written on? I don't know. So yeah, perhaps you hinted at the answer to this question earlier on, where you mentioned about machine learning algorithms advancing in the past few years. But yeah, what should I say to him in the pub on Sunday when I go for a beer with him?
Yeah, I mean, I think there are a number of different answers. The most basic answers, with the techniques that we have today, we can do exactly what a person would do. So a lot of times you'll be digging maybe this buried pipe, and you pack that pipe in gravel and then bury it under dirt. You can feel or hear that gravel being pulled up, and we will do that same thing. Or there's tape; you can detect that tape. That gets us to the same level of performance as a person. Then the question is, how do you become superhuman? And so techniques like ground penetrating radar, using surveys, and like one of the things that happens a lot around these sort of obstacles underground is you're only supposed to dig a certain depth, and then you go in with a shovel and you dig a little bit further, and people will they get tired, they get bored, and they like dig a little extra far,
A little
right?
bit more.
And then they hit the pipe, and so machine just never gets tired, right? Ground penetrating radar could be amazing, and to the sensor fusion point, when you use a ground penetrating radar as a person, you really only see a few feet underground, so you have to go back and get a person out, get a cart out, and re-roll it over this thing that you're digging over and over again to confirm the depth of whatever's underground. The robot could have that in its bucket. There are tools out there that exist. Another machine could come in and do that work, and if that was an automated machine, it might not cost you much to go rescan over and over again. We can integrate that perfectly into a map, and produce a solution. So we're exploring all of those options right now. Yeah, the short answer is I think we need to be really, really good at that.
Fair enough. Hey, if you ever need a design partner over here in the UK, then hit me up. I'll hook you up with my dad.
Will do.
Sorry, I got one more.
Yeah, Patrick.
Kevin. So I'm going to take us a little bit zooming out here. Okay, so someone with your resume and your entire founding team resume, you guys had choice, right? So you you decided to go into construction. A lot of teams with your background would have actually chosen defense in the current environment. What was it about construction that made you actually say, no, this is actually even cooler, that's a bigger opportunity?
Yeah,
Nice.
of course, defense is important. We are really excited about bringing a product into the world that's going to accelerate building the world. That's kind of the problem, the promise of robotics and the promise of AI. And so many of these tools sort of like automate stuff that's already happening, or like organize your data or something like that. If we can get machines working together more efficiently, if you can rent a machine, put it on a site, and start doing work out of the box, if training is easy, if just about anybody can get in a machine and use it, then these projects are going to fly in a way that they never have before. That's the future. Robots doing work in the world and making our lives better is just such a dream. That's what we're excited about. Construction is just about the most direct way that you could imagine doing that. It's also just a massive industry. I mean, it's like huge. So we think it's important. We think it's the future. We think it's obviously going to happen. We think the technology's ready. And we also just love the projects we're on. We're working on, massive roads. We're working on infrastructure for cities, dams, building the power. I mean, I don't know, honestly, why you would go anywhere else.
Cool. I think you cannot end on a better note. If you need more context in the road building, highway, infrastructure space, hit me up, by the way.
All right. Yeah, we'll do. Thank you.
Awesome. Nice. Okay, Mo, do you have a final one? I know last time you said no, so I don't want to put you on the spot again, but maybe you thought of something in between.
No, I have no final question on this topic. I'm good for this one.
Very good. Cool. Well, Kevin, we will let you go. Thank you so much for joining us. We really appreciate it, and best of luck with Bedrock. Very exciting for the space. You guys. So I'm sure lots of people will be watching and cheering for you.
Thank you. Appreciate the chance to be on the show.
Best of luck.
Sure.
Man.
Bye.
Good meeting you.
Whoa, very educational.
Bright.
You feel
I
smarter?
think bright future for robotics in our space.
I think it's very exciting. I was getting very excited when Kevin was speaking there, and just thinking about, like, as I mentioned earlier, some of the funding rounds and some of the people now within the industry. Construction is making it to the mainstream.
I mean, for me, it already is. So
Yeah, of course. Yeah. Mo, do you have any news for us?
I have no news, but I can give you another idea around the robotics and self-driving. I think, I don't know if you talked before about it, but one of the biggest things now happening, or people now trying to build companies or products around, is, I mean, if you don't have the driver in a self-driving Waymo, yeah, who cleans the car?
Especially if the
So there's
passenger
like
is sick after
multiple
a drunk night out.
companies. Yeah, is how you build autonomous cleaning machines or car wash, or especially for the interior now of self-driving cars. That's like a big research. I don't know, a few months ago, I said, oh, that's a great idea, and look into it. I know there's like 6 to 8 other companies from large to small trying to solve that problem.
Wow.
I think it's always to think about, okay, what happens if the operator is not there? Because usually operators do more than operating the machine, because imagine the operator also cleans usually the equipment.
Mhm.
Who will get that task now afterwards? Who fills it up with the gas? So there will be different roles and job shifts also in construction if we shift around. And then you have to think,
Yeah.
okay, how really the operation and workflows change for these people? Because you probably will not hire just one person just to clean, or maybe you do the vehicles in between, or who takes care of those things, because operators do much more than being on the equipment.
Yeah.
So that's like something to think about, how, let's say, the second level effects are of automation always, and
But
what
that's
is
always
opportunity there.
Mo, that I'm fascinated by that topic, actually, because I'm a trained economist, and I'm fascinated always by how, when you transform the supply side, you can actually transform parts of the behaviors too. And the way you are describing it fits perfectly into how I see generally the world as an investor, is from the capacity in the supply side. And so here, if you transform the capacity of, okay, there's actually self-driving cars, you're going to create much more incentives to build other types of capacities, because you're really rewiring parts of the industry. Many people then wouldn't notice that is actually happening until it's completely obvious. And so here's a fun metaphor, or actually fun anecdote. So when gas stations were being rolled out, to a large degree, we created a new type of supply and created the capacity for it. Do you guys still know how actually gasoline was distributed before we had enough capacity of gas stations?
Nope.
Somebody would drive around with a tank.
More crazy than that.
Someone would walk around.
Drugstores. It was actually pharmacies who sold gasoline.
Yeah.
Right? And so if you roll out new capacity at a large enough scale, the rest of the supply will then transform too.
Yeah, but I think also that's like very interesting to think about, okay, what are if you're building a new company or new business, what are the effects of the not obvious ones now, which we see? What is like the other things which you would need, or new capacities to build around?
Exactly. Yeah.
Mm-hmm. Nice. Well, I guess we can wrap up.
Let's do it.
Was great chatting
Thank
with you guys.
Thank you both. Yeah, great show.
Great
Thank you.
topic.
Likewise.
Anytime you want to come back, Mo, you just let us know.
We do.